talk about serendipity. Does technology, do these kinds of tools increase, decrease the serendipity, the exploration element of learning in the classroom?
I think it greatly enhances the idea of exploration and experimentation. I mean, that's something I've been sharing with other educators for years with how Mathematica has changed my classroom conversations. Is my students don't ask me so much anymore, what's the answer, or how do I get the answer? They ask me, how does this connect to that? What would it look like if? Can we change this? How does this connect? So and we can answer those questions in real time when we have these kinds of technological tools versus that's beyond the scope of this class, or I have to prepare transparencies for that for next time. You know, here you can do things right away, and you can have the students ask questions that even, you know, I don't know the answer to. And I'm very comfortable saying I don't know, and we figure it out together. And the students, when they get their hands on the technology directly in their computer lab setting or at home, they dive right in and try to figure things out, and they push it.
Math as a process rather than a procedure, and that's what math is. It is a process, and it's about building connections, and that's exactly what you're doing with your students.
I think Alpha actually is very good at that, because when we first started experimenting with Alpha back in May, a bunch of us instructors, we were looking at, in particular, how when you give Alpha a query, it gives you a lot more than what you were intending to get. Now, when you ask Mathematica for something, you give it very specific code, you know exactly what you want to get out, but with Alpha, you put in a function, and you get not only a graph of the function, but you get the zeros of the function, you get the derivative of the function, you get the real and imaginary parts on the graph, and all of a sudden you find yourself having conversations about math that you don't normally talk about. It's like your example with trigonometry. A student says, why is there two parts to this graph? Why is there a blue part and a red part? Oh, well, the red part's the imaginary part. And now you find yourself in a conversation that you haven't had, you know, since grad school, essentially teaching at this level. But they are seeing the connection between everything, and they didn't ask for it, which I think is one of the real beauties. It just showed up.
It introduces students also to the larger world of mathematics, which one of the funniest questions I get from my students. I teach the highest level math classes in our school, and these are actually, I'm teaching college level courses in the high school, and a lot of times kids ask me, what's the highest math? Because they know they just keeps going. They just think it keeps going. They don't see the branching off that mathematics has. Like science, you know, they see, oh, there's biology and physics, you know, and math kind of has its own branching that they get to later. So with things like Wolfram Alpha that kind of shoots out some more information, it's like, wow, what is this? There's these other things out there that I haven't seen, and maybe my teacher doesn't know everything. Maybe there's, you know, more things to look at and learn.
Do you still get the question, though, that I sometimes hear from parents, which is, what about the fundamentals? How is my kid going to learn the fundamentals of math?
Who defines the fundamentals?
Okay.
Is there a board somewhere that you know puts forth the table, the
commandments? I learned it in high school, so therefore it must be fundamental, right?
But that's how we feel about everything. I mean, if that's how we approach the world, then we would all still be driving horse-drawn carts, because you know that's important to know that fundamental of how to, you know,
get a horse down the road.
As a high school teacher in California, we're handed lists of standards that we have to teach to, and that the kids are assessed on at the end of the year. So we're still responsible for the fundamentals, the basics, as they're defined by the great, you know, them out there. And but the thing is, even with the technology, the students have to know the basics, and because they have to know that what they're getting out is reasonable, and that their answers make sense, and then how to use them to build onto other things. Every time when I'm using Mathematica in class, if like in my lecture notes, we do the examples traditional ways and work out the problems, and we get a result, and then we say, okay, what do we think this would look like? We're always predicting before we use the technology, so that we can then say, okay, does this match our predictions? Why or why not? And I encourage that kind of thinking about it versus just the computer will give us the answer. We want to try to make sure, that what the computer is giving us is accurate, because all it takes is you know, typing something in incorrectly, you know, whatever type of graphing calculator, Wolfram Alpha, Mathematica, or other software, and you get a wrong answer. And if you just implicitly trust that answer and move on, then that's problematic. That's going to create issues down the road.
There are a lot of paths to creating and developing the fundamentals in someone. And I think that using Wolfram Alpha or Mathematica or whatever, my students learn, they use Mathematica to calculate derivatives, and they don't ever do them by hand until they do a test. But they can do them on the test. So they know the fundamentals by the time they get there.
It sounds like you're really building instincts for math
Exactly.
into what the way you're teaching and the way your students are understanding math, real instincts for what this math means in the real world. I guess the other question I have to come to is, how many ways do you see your students connecting to things that are not considered mathematical, to things that are in the real world?
One of the projects that the students have to do is, at some point during the semester, they spend 1 unit being a blogger. And so the class is split up into groups. And so at any given time, there are about 5 or 6 of them who are bloggers. Right. And they write about what they learn in class and how it applies to their life, the resources they've gone out and find that relate to class. And often I'll get stories from them in their blog posts about how they didn't realize that there's so much algebra out there. It's not in X's and Y's, but you know that it's there, and they saw it in their kids' football game and things like that. So I'm trying to create opportunities for them to really think about engaging with math outside of an academic setting.
That's great.
My students love to do projects that connect math to other topics. In class where I have the students using Mathematica a lot, they are always looking for projects in their physics classes, biology classes, economics, or art, or music. And having these tools lets them really find those connections and work it out. Students in my more traditional classes, we do final projects at the end of the year, and I let them choose their topics. And they're always reaching out for those connections, and they really enjoy when they see that this math that I've been learning is actually useful for something, and it does connect to something else.